What's up, everybody? It's Dan from SageMathTutoring.com, and here with a video featuring a review sheet for geometry, and let's get right to it. Okay, so problem number one, the sides of a right rectangular prism are 6, 7, 8. What's the volume of the prism? So the prism sort of looks like this, right? Maybe not drawn to scale though. Let's call this 6, let's call that 7, let's call that 8. Okay, so the volume is going to be a matter of multiplying the area of the base times the height. Okay, that's a very sort of famous way of looking at it. So we have the area of the base times the height. Now the area of the base obviously is 6 times 7, and then times the height would be 8. So that's going to be equal to 336. Okay, so that's that one, 336. All right, looking at problem number 2. What is the surface area of a cylinder with a height of 7 and a diameter of 14? So sort of drawing the situation, not a bad idea to draw it. It's the case that the height is 7 and the diameter across is 14, and we want the surface area. Now the surface area of a cylinder is going to be 2 times the area of each base. So we have a base on the bottom and we have a base on the top, right? So it's going to be 2 times the area of each base plus, let's see, the circumference, which is 2 pi r, times the height, okay? Now it so happens, though, that the area of the base is the area of a circle, right? So we could say, really, that the surface area of a cylinder is 2 times pi r squared plus 2 pi r times h, which is the height. At that point, it's just a matter of filling in the proper numbers. So we have 2 pi. Now the radius is going to be half of 14, so that's going to be 7 squared plus 2 pi times 7 times yet another 7. And that turns out to be, let's see, 98 pi plus, I guess that would be another 98 pi, to be honest. And then you could combine those to say 196 pi. Okay, now the reason I'm leaving it like that is because they did say do not use decimals unless told otherwise. So we're going to leave it sort of with that pi in there. All right, so hopefully that makes sense. And hopefully my calculations were correct. But as long as you understand the formula and all that good stuff, that's what really matters. Okay, problem number 3. If the slant height of a right cone is 10 and its base is a radius of 6, what's the surface area? Okay, so here's a cone. The slant height is apparently 10. The radius of this circular base is 6. And we also know, what else do we know? That's all we know. Yeah, so that's tricky because the surface area of a cone is going to be the area of the base plus pi r times the slant height. So the area of the base is, of course, going to be pi r squared, so we could sort of write that as well. And we are therefore ready to go ahead and plug in numbers. We have 6 here, 6 there, and also 10 there. So we have 6 pi plus 60 pi, also known as 66 pi. So that's the answer with that one. All right, looking at problem number 4. What is the height of a cone with volume 12 and the radius of 2? So the volume of any cone is 1/3 pi r squared times the height of the cone. So we have this cone here, and we know that the volume is 12, so we can say 12 equals 1/3 pi times whatever the radius is. Now the radius is apparently 2, right? And we want to solve for the height, okay? We're trying to solve for the height. So how do you do that? Well, one thing you could do is you could get rid of this 3 that's right here by multiplying everything by 3. I mean, that's something we could do. I'm kind of a fan of going about things in a systematic way, though, and the systematic approach would suggest that we simplify both sides as much as possible first, and that would be a matter of applying the exponent of 2 to that 2 right there. So I just did that. And then it would be 4/3 actually, pi times h equals 12. And it's also the case that we are indeed trying to get this h by itself. So one thing we could do right away is we could get rid of that 4/3 by multiplying both sides by the reciprocal 4/3, which is 3/4, right? 3/4. And then cancel, cancel. Next thing you know, we have 9 equals pi times h, dividing both sides by pi, and you get 9 over pi, and then you're done. Okay, looking at the next one, which is problem number 5. So, problem number 5 says, what is the volume of a sphere with a radius of 6? So the volume of any sphere is going to be 4/3 pi r cubed. So all you have to do is just plug in 6 for r, and then you're good to go. Okay, so we have 4/3 pi. 36 times 6 is 108, I believe. So yeah. So then that's going to turn out to be 144 pi. Okay, so that's how you do that one. Find the surface area of the right cone with radius of 4 and height of 3. So once again, surface area of the cone would be pi r squared plus pi r times the slant height. So we're just going to plug in the information. We have pi, radius is 4. I'm going to just not draw the cone this time because I feel like this one's actually pretty straightforward. You just plug in everything. Well, actually, no, you can't because they give you the height. They don't give you the slant height. So I stand corrected. We're going to draw this. So the case with this one is that uh, that's 4. Okay, so we have that radius of 4 there, but now they're also saying that the height right here is 3. So it's up to us to find the slant height. Now the slant height is this green part. Okay, and the way to do that is to just recognize that there is a right triangle being formed in this case, where the blue side happens to be 3, the bottom happens to be 4, and if you were to do the Pythagorean theorem, you would quickly realize that that's 5. That's also a Pythagorean triple. It's a famous, famous triplet of side lengths for a triangle. Okay, so the slant height is 5, so cool. So we're going to put that here. Therefore, we're looking at 16 pi plus 20 pi, aka 36 pi, and that's how you do that one. All right, find the volume of a cylinder. I'm going to draw it with diameter 10. Okay, cool. 10. And a height of 8. All right, so that's 8. Volume of a cylinder is pi r squared times the height. So the radius is clearly 5. So that's going to be 5 squared times 8, which is 25 times 8, which is 200. Therefore, it would be 200 pi, and that's how you do that one. All right, find the surface area of a square pyramid. Its base is 3 by 3, and its slant height is 5. So here's a square pyramid right here. I'm actually going to start by drawing that. I'm going to draw a dot above, and then I'm going to do this. All right, that's probably the best way to do it. So find the surface area of a square pyramid, 3 by 3 down here. Okay, so the surface area of a square pyramid is going to be the area of the base plus 2 times, and we'll call this S for side length, times the slant height, which I'm going to call L, okay? Now, the area of the base is this red part. That means that we're going to take into account the area there. Now, it is the case that the area of a square is side times side, so we could say that it's side squared here, okay? Kind of write that in red. We could say it's side squared because that's the area of the base. So then it's going to be 2 times whatever the side length is times whatever the slant height is. So then the side length clearly 3, so we're looking at 3 squared plus 2 times 3 times the slant height, which happens to be 5. So we're looking at 9 plus 30, aka 39, and that's how you do that one. Okay, looking at problem number 9, which trapezoids shown are similar? So you know they're similar if the side lengths are proportional. Let's call this trapezoid A, trapezoid B, trapezoid C. Let's investigate trapezoid A and B by sort of comparing their side lengths. So we have 2 over 4, and the question is, does that equal, and by the way, I got that from these, 2 over 4. The question is, does that equal radical 2 over 2 radical 2? And the question is does that equal 3 over 6? And the question is does that equal this 2 over 3? So that's the question. Well, 2 over 4 is certainly 1/2. These would cancel, leaving us with 1/2. 3 over 6 is 1/2, but the problem is 2/3 is not equal to 1/2, so therefore A and B are not proportional. Let's now investigate B and C. So we'll put B on the top and C on the bottom. That actually doesn't matter. Just make sure you're consistent. So we have, let's do the top side there. That's 4 over 5. And the question is that equal to 2 radical 2 over 5 radical 2 over 2? We're going to find out later. And then is that equal to 6 over 15 over 2? We're going to find that out later. And then is that equal to 3 over 5? So let's see. This right here is really going to be 2 radical 2 times the reciprocal of the denominator part. And it is the case that the radicals would cancel, leaving us with actually 4 over 5, because these would multiply to the 4, and then you would have the 5 left over down below. So that actually does check out. With regards to this one here, this is secretly 6 times the reciprocal of 15 over 2, which is 2 over 15. And the 3's would cancel out, so we would have a 2 here, we would have a 5 here, and lo and behold, you would indeed have a 4 over 5. And then over here, though, let's see, this is a 3 over 5, so already that's a problem, right? So we can't have that. So then the question is, because that's 3/5, this is 4/5, this is 4/5, this is 4/5. So the real question is okay, well, what about A and C, right? What about A and C? So let's see, we'll put A on top, we'll put C on the bottom, and the side lengths for A would be 2 over 5, and then we could say radical 2 over 5 radical 2 over 2, and we could say that that's equal to 3 over 15 over 2. We could also say 2 over 5, right? Well, these certainly check out, right? But the question is, what's going on with the 2 middle ones, which are sort of a mess, right? So we could wrap that in parentheses. We have radical 2 times the reciprocal of the denominator, which is this. And it's the case that the radical 2's would cancel, leaving us with 2 over 5. So it looks like that one checks out. Let's wrap parentheses around that 3. We have 3 times the reciprocal of 15 over 2. And that would turn into a 1, that would turn into a 5. And that would indeed leave us with 2 over 5. So it is the case that the proportions are all 2 over 5. So therefore, the answer is that A and C are similar. Okay, looking at this one, parallelogram is similar to blah, blah, blah. Find EF. Okay, fine. So we want to find EF. Let's see. So AB corresponds with EF, apparently. So we have these things right here. And the question is, how did we get from 3 to 9? Well, we would have had to multiply 3 times 3 to give us 9. So we're going to do, the same thing to this 2 to find the x. So 2 times 3 is 6. So x equals 6. That's how you do that one. Number 11, RST is similar to VXY. If angle R is 110, okay, label. If angle V is equal to 110, okay, cool, label. And angle Y is equal to 15. Make that look nicer. Find angle S. Okay, so they are similar, and if that's 15, then this is 15. And because all interior angle measures of a triangle add up to 180, we know that this right here we could call x. It's really the case that we have 110 plus 15 plus x equals 180. And then if you were to solve for x from there, you would have 180 minus, I guess, 125, which is 55. Okay, so there we go. Okay, I think I'm actually going to do 12 on the next page. Okay, looking at number 12. So apparently ABD, which is this large triangle, is similar to ECD, which is the smaller triangle, and it's the case that DC equals 6, EA is equal to 4, and DE is equal to 3. We want to find CB. So the reality is that these are parallel lines, which means we could set up awesome proportions. For example, we could say 3 over 4 is equal to 6 over x, okay? And that's what we're going to do. We're going to say 3 over 4 is equal to 6 over x. Cross multiplying gives us 3x equals 24. Divided by 3 gives us x equals 8. And therefore CB is equal to 8. Okay, so this is my fault. I actually cut off, when I took a picture of this problem, I cut off information on the bottom. So unfortunately, we do not have enough information to solve this one. It wants us to find all possible values of x for the following figure. But unfortunately, we would need information down here in addition to this stuff up here. It is the case that the large triangle happens to be proportional to the smaller triangle, that's for sure. Okay, use the figure below for questions 14 and 15. Below parallelogram ABCD is similar to OLMN as shown below. Okay, cool. We want to figure out what X is. So it is the case that AB corresponds with OL. So this AB corresponds with this OL right here. Let's see. It's also the case that BC corresponds with LM. So here's BC. LM is right here. And in order to get from 6 to 3, we have to divide 6 by 2 to get 3. So if we could just figure out what this is, all we would have to do is divide it by 2, and we would have what X is. Now, it is the case that since this side happens to be 9, opposite sides of parallelograms are congruent. So that means that this side also has to be 9, which means that, this 6 divided by 2 gives you 3. So therefore, this 9 divided by 2 is going to give us 4.5. So that should be 4.5 right there. Okay, so that now they want to know what y is equal to. Y is right here. So if we look at this parallelogram, we see that that's 50 degrees, which would make this 130 degrees because consecutive angles in parallelograms are supplementary. So that's 50, that's 130. This would have to be 50, that would have to be 130. So it looks like all the acute angles in this parallelogram are 50 and all the obtuse angles are 130. So that's something to keep in mind for sure. And we also know that similar polygons have congruent interior angles. So in other words, all the angles that are inside this polygon have to be literally the same angle measures that are present in this parallelogram as well. And this certainly looks like it's acute, but let's kind of investigate a little further. Because if it's acute, then it should be 50, right? So we're going to label that red. So AD is labeled red, and DC is labeled blue. So let's kind of do the same pattern over here. ON is red, and MN is blue. So we're going to make this blue, and we're going to make this red. So what we can see is the angle that's between the red and the blue side is going to definitely be equal to the angle that's between the red and the blue side over here as well, because they structure these letters in a particular order to let us know that AD corresponds with ON, CD corresponds with MN, and therefore the angle between these sides has to be the same. So that's 50. Okay, finding the value of x. Let's see. Well, it certainly seems like these should be, yeah, these are going to be similar because due to the third angles theorem, we know that this angle has to be equal to that angle. And since all of the angles on the inside are equal to each other because we have 90 degrees, 90 degrees, this angle is equal to that angle, this angle is equal to that angle, then we know that these triangles happen to be similar, which means that the side lengths need to be proportional. We'll call this the large triangle, and we're going to call this the small triangle. So what happens if we put corresponding sides of the large over the small? You know, what would happen? Well, we would say that x is over 6, right? Because x is corresponding with 6. X is the side that's between the double rainbow green and the 90 degree, and 6 is the side that's between the double rainbow green and the 90 degrees. So it makes sense that we can set that up, and we can set that equal to, we still want to keep the large on the top, right? The large remains on the top, so that's going to be 12 over 4. Now, for the record, we could have done small over large as long as you're consistent all the way across. At this point, we're cross multiplying, or really we only have to multiply both sides by 6. So we would have x equals 12 over 4 times 6. Now let's kind of work with this a little bit. This could become a 3, that could become a 1, and 3 times 6 is definitely 18. Okay, looking at this one, find the value of x. Okay, well, once again, you can set up a proportion. You can say that x plus 1. You can basically say that this part over this part is going to be equal to this part over that part. All right, so we have x plus 1 over x minus 2 equals x minus 1 over x minus 3. And the reason we can get away with that is because these are parallel lines. Okay, so at that point, cross multiplying, you would end up with scenario where it's x plus 1 times x minus 3. We have x minus 2 times x minus 1. If we were to FOIL this one, then we would have x squared minus 2x minus 3. And if we were to FOIL the thing on the right, it would be x squared minus 3x plus 2. At that point, we can cancel the x squared terms, and we would have, of course, negative 2x minus 3 equals negative 3x plus 2. Let's commit to having the x's on the left, and I could add 3x to both sides. That gives me x on the left. I could add 3 to both sides, and that's going to give me 5 on the right. Okay, so that's how that would work. Number 18, the shadow of a 5-foot person is 7 feet long. How long is the shadow of a 15-foot pole? Okay, so here's a person. Yay, person. And 5 feet tall. And we know that the shadow, therefore, is 7. So that means that the sun is like here. Yay. All right, shadow, casting a shadow. How long is the shadow of a 15-foot pole? So let's assume that, I mean, what they're really saying is imagine the 15-foot pole was in the exact same position. How long would the shadow be? Well, the idea is that it would be proportional. So we have 15, and we're essentially asking what is that x right there. I mean, you could kind of think of these as triangles, right? You could think of them as triangles. And then, you know, they're 90 degrees, 90 degrees. And just setting up a proportion, we could say large over small. This is the large one. This is the small one. So following through with that would give us certainly 15 over 5 equals x over 7. 15 over 5 is just 3. And what we could do is we could multiply both sides by 7. And then x would end up being 21. So the shadow for the 15-foot pole would be 21 feet long. All right, number 19. The ratio of the two areas of a circle is 16 over 25. What's the ratio of their circumferences? Okay, so area is a second dimension measurement. You know, this is like units squared, all right? Whereas circumference is a single dimension measurement. of length, right? So believe it or not, all you have to do to find the proper ratio between the circumferences is to literally just take the square root of these, and that would give you 4/5. And that's all you have to do to turn the ratio of a second dimension measurement into the ratio of a one dimension measurement. Okay. Because this is units squared, whereas we're looking for just units, not units squared when it comes to circumference. All right, number 20, sphere A has a radius of 4 inches, sphere B has a radius of 5. What's the ratio of the volume of sphere A to the volume of sphere B? Okay. So, radius is a single dimension measurement of length. And we know that the ratio of those dimensions is 4/5. So if we want the ratio of the volumes, then volume is a cubic measurement, which means it's sort of like an exponent of 3. It's a three-dimensional measurement, we could say, because think about volume. Volume has to do with 3 dimensions, right? Area has to do with 2 dimensions, and length has to do with 1 dimension. So volume has to do with 3 dimensions, which means we got to take this single dimension measurement and we need to cube it. Okay, so we would have 64 over, I believe, 125. So that's the ratio of the volume of sphere A to the volume of sphere B. Number 21, a line that touches a circle at 2 points is called a secant line. Okay, so it's not a segment, it's a line. So we have a line, which means it goes on forever, but it hits 2 points, we call that a secant. A segment with endpoints on the circle and passes through the center. Okay, so here's the center. We have a segment that goes from there to there. And one endpoint on the circle, another endpoint on the circle. We call that the diameter. It's just vocab, really. Give the center of the circle with equations shown below. So the center is going to be 6, 8, and the reason for that is because the standard form equation of a circle is this, and you should know by now that the center will always be hk. Now think about it. H is the number that's being subtracted from x. K is the number that's being subtracted from y over here. So what's the number that's being subtracted from x? 6. What's the number that's being subtracted from y? 8. So it will always result in a situation where the center, coordinates of the center are always going to be the opposite sides of these numbers. That will always be the case. Give the radius of the circle with the equation shown below. Okay, well, that should be r squared, right? Because apparently the equation of a circle is such that there's an r squared over here. So we can say that, okay, cool, 100 equals r squared. What is r then? Well, r is 10. Therefore, because you could take the square root of both sides, and the square root of 100 is really plus minus 10, but since we're looking at an actual circle, it's going to be the positive 10. Okay, so that's that. 25. Find the x-intercepts for the circle with the equation shown below. So you always know the x-intercept because it's going to be whatever x equals when y is 0. So we're going to go ahead and just set y equal to 0 and kind of figure out what the rest of this thing is. So it's going to be 0 squared equals 49. So clearly we're looking at x plus 3 squared equals 49. At that point, you can divide both sides or take the square root of both sides. You would have x plus 3 equals plus minus 7, actually, because when you take the square root of both sides, you could do plus minus right there. And at that point, you could then subtract 3. Well, really, let's actually split this. So you could say that it's either x plus 3 equals positive 7 or x plus 3 equals negative 7. X, therefore, equals 4 over here, and x equals negative 10 over here. So the x-intercepts, in other words, the places where the circle crosses the x-axis, are 4, 0 and negative 10, 0. The y-coordinates of x-intercepts are always 0. Find the y-intercept for the circle with the given equation shown below. Okay, so if you want to find the y-intercept, you just set x equal to 0 and solve for y. So we have 0 plus 3 squared plus y squared equals 49. So we'd have 9 plus y squared equals 49. Subtracting 9 from both sides gives us y squared equals 40. Taking the square root of both sides, y equals plus minus the square root of 40. Radical 40 could be simplified into 2 radical 10. So the y-intercepts would be 0 comma positive 2 radical 10 and 0 comma negative 2 radical 10. Those are the y-intercepts. 27, for the circle below with center C, find the measure of the minor arc AB. Okay, we want to know what this arc is here. Well, the measure is always going to be equal to the central angle, so that's 104, and that's that one. Find the measure of arc BC. Okay, so BC is right here. So this angle is 28 right there. So the theory that you need to understand is that this angle 28 is always going to be 1/2 times the larger arc minus this smaller arc here, okay? So it's going to be 1/2 times 103 minus, we'll call the smaller arc x. We need to figure out what that is, right? So that's x. What I like to do with these is I like to get rid of the 1/2. Rather than distributing, I would rather just literally multiply both sides by 2, okay? Because these would cancel. Next thing you know, you have 56 equals 103 minus x. At that point, I'm going to add x to the left, and I'm going to subtract 56 from 103, and that's going to give us, let's see, 13 minus 6 is 7, 47, okay? So the measure of that arc BC, is 47. Find the measure of angle XYZ. So XYZ is right here. Okay, so that, we'll call that X. So that is always going to be 1/2 the sum of this angle and this angle. So it's going to be 1/2 the sum of 150 plus 60. And 1/2 of 150 plus 60 is really 1/2 of 210, which is really 105. So that's the measure of that angle. Looking at problem number 30, find the measure of arc AB. So that's right here. Well, that's actually pretty easy because the measure of this arc is 80. The measure of this arc is 100. So already that's 180. So all we would have to do to figure out the blue arc is to say, okay, what's 360 minus 180? And that's going to be 180. So yeah, that diagram is really not drawn to scale. So then they say ACB is this angle. They want to find it. Well, that's going to, if this 180, that's going to be 1/2 of 180, which is 90. That's the theory that you need to know for that. Hopefully I didn't do that wrong. That one's weird. Let's see. Problem number 32. Find the measure of segment AD. So we want to find this thing. We know that AE happens to be 16. We know that AC happens to be 8. And we know that AB happens to be 10. Let's call this X here. So it's a matter of just memorizing that 16 times X is going to equal 10 times 8. So it's always like this thing times that thing equals this thing times that thing. So we're looking at 16x equals 80. 80 divided by 16, I believe, is 5. Yep. Yeah. So that's that one. 33, find the length of YZ. So XT is 4. TW is 10. XZ is 5. And we're looking for a segment YZ, so obviously we're looking for this one here. Let's call it X. So the pattern that I'd like my student to remember is that this sort of part and this whole has a special relationship. and this part and this whole have a special relationship, and that relationship is that the 4 times the entire thing here, which is 14, is going to equal this 5 times the entire thing, which is 5 plus x. So it's going to be 5 times 5 plus x. Distributing 25 plus 5x, 4 times 14 is 40 plus 16, which is 56. Subtracting 25 from both sides would give us 31, and then x would therefore equal 31 over 5, which is like 6 point something. Okay, looking at the next one, CB is 2, so that's 2. BA is 6, and we want to know what this is. Well, it's really the same thing. If you think about it, it's kind of the same pattern, actually. It's going to be really this thing times the whole thing is equal to this thing times the whole thing, which just happens to be itself. Okay, so we literally have x squared equals 2 times 2 plus 6, which is 8. So that's going to be 16. So x squared equals 16. X therefore equals plus minus 4, but we only need to worry about the positive value. All right, looking at 35, in a circle with diameter 8, find the length of the arc in centimeters made by the central angle of 20. So we could say arc length. I mean, this is the formula that I like the best. Others might disagree. But it's arc length over circumference, which is really 2 pi r. And that's going to equal the central angle over 360. And we could just literally use that formula. So problem number 35, circle with diameter 8. So the radius is clearly 4. And we want to find the central, or the arc length rather. So let's say x over 2 pi times 34, or times 4 rather, I don't know what I'm saying, times 4 is going to equal the central angle, which we already know is 20 over 360. Now, it's very often the case that you could just kind of simplify the side. The zeros would cancel because really it's 20 divided by 10, 360 divided by 10. And then the 2 and the 36 could cancel as well. Like the 2 becomes a 1, that becomes an 18. So what we really have then is x over 8 pi equals 1 over 18. At that point, we can, multiply both sides by 8 pi. We would have x equals 8 pi over 18, also known as 4 pi over 9. So that should be it. Okay, so that is that one. Let's look at problem number 36. So the circle with radius 5 centimeters. Find the degree measure of the arc with a length of 9 pi. Okay, so now they're giving us the arc length, and I guess we're trying to find they say they want to find the degree measurement of the arc, so let's just paint a picture of what's going on. So we have 5, we have that. We have a central angle, which we'll call x degrees. Now, x degrees is going to be the same as the sort of degree measure of the arc, okay? Because the degree measure of an arc is always going to be the same as the degree measure of the central angle that intercepts that arc, okay? So when they say they want to find the degree measurement of the arc, what they really sort of are saying is what's the central angle? And once again, we can use that same formula that we had before. It's going to be arc length, in this case is 9 pi, over the circumference, which is 2 pi, times radius, which we know is 5. And that's going to equal the central angle, which is x over 360. At that point, the pi's would cancel, which is great. We would end up with 9 over 10 equals x over 360. At that point, we could multiply both sides by 360, and what you would get at the end of the day is 324 degrees. Okay, so this is not drawn to scale. Okay, so that's that. Let's see, looking at problem number 37. In the right triangle shown below, okay, looks like we're going to have to go to the next page. In the right triangle shown below, tan of A is, okay, so A is right here. SOHCAHTOA, remember, suggests that the tan of an angle is always equal to opposite over adjacent. So the opposite, we can say tan of A is equal to opposite over adjacent, right? And the side that happens to be opposite to A is this right here, which is A. And the adjacent side is this side right here, which is C. So we don't want to confuse it with a hypotenuse. This is the hypotenuse, right? Hypotenuse is just the hypotenuse, whereas this is the adjacent side. So A over C is actually the answer, kind of a weird, funny answer, but that is the answer. All right, find the exact value for the following trigonometric functions in simplest form. So sine of 30, Well, it is the case that my student has learned about 30, 60, 90 triangles. So I don't mind like going there. It's also the case my student has learned about 45, 45, 90. Now, in the case of 30, 60, 90, if this is like x, then the hypotenuse would be 2x, and this would be x root 3. In the case of 45, 45, 90, this could be called x, this could be called x, and this is x radical 2. I think that's going to be helpful for us for quite a few of these, okay? Or maybe even all of them. So let's see, sine of 30. So sine of 30 would be this scenario, and sine, according to SOHCAHTOA, is, you know, right here. That's opposite over hypotenuse. So we're looking at the opposite over the hypotenuse. So that's going to be x over 2x, which really just ends up being 1/2, and that's it. Cosine of 45. Cosine is adjacent over hypotenuse. So 45 is right here. We have adjacent, which is x over x radical 2. So let me write it over here. Cosine of 45 is equal to x over x radical 2. It's the case that the x's cancel, leaving us with 1 over radical 2. Multiplying the top and bottom by radical 2, because sometimes teachers don't like radicals in the denominator. The bottom part, this part, would be radical 2 times radical 2. That literally just turns into 2. And then up top, we have a single radical 2 over 2. So that's the answer to this one. It's radical 2 over 2. Tan 315. So at that point, I would start to think about the fact that that's 0, that's 90 degrees. This is 180 degrees. This is 270 degrees. And we could also say that, yeah, this is 0, but it's really 360 degrees. So you want to imagine that all angles start here, and then they kind of open. You know, if I was conceptualizing a 90-degree angle, it would start there, and then it would open counterclockwise there. If I was conceptualizing 180 degrees, it would start here, move counterclockwise, and then it would end here on 180, okay? So that's the reality of angles on the sort of coordinate plane. So when we say 315, we know that's going to land somewhere here, right? But let's think about it. It would land somewhere here, but what's the difference between that 315 angle here? What's the difference between that 315 angle and this 360? Well, 360 minus 315 is 45. So we could sort of hypothetically create this triangle where there's 45 degrees right there, which makes this 45 degrees. And we want the tan of that, right? So the tan is, according to our system, opposite over adjacent, right? So what we're really looking at is this part, which is the opposite of this 45, because we're going to use this one. It's the opposite over the adjacent. Now, I'm going to say we can stick with this sort of structure here where the side that's opposite of 45, we're just going to call x. But actually, I'm seeing to avoid some potential confusion, we're just going to replace that variable with an a. Okay, we're going to replace that with an a. It's all the same, but I can see there's something that might come up that might be confusing soon. So the side that's across the 45-degree angle is A, and the side that's adjacent to the 45-degree angle is A. So we're gonna do the same thing over here. We're gonna say that that's A, but we're gonna call this negative A, and the reason is because this is really a vertical distance downward. So you're gonna want to assign a negative to it. Now this we could call positive A. Okay. So what's the tan of 315? Well, that's going to be negative A over positive A. But wouldn't that just be reducing to negative 1 over 1, which is also known as negative 1? So that's that. Let's see, tan of negative 330. So if we have this structure again, 0, 360, we have 90, we have 180, we have 270. Tan of negative 330. So if it's negative, that means we're going in this direction instead, 330 degrees, which would land us right around here, right? So we have some triangle that we can imagine here. And this angle is going to be 30 degrees because if you think about it, we went all the way around 330 degrees, and then it would be an extra 30 degrees to get to that 360 mark, right? So we are therefore analyzing this triangle. And once again, I'll sort of replace these x's with an a just to avoid some potential confusion. So we'll call that a, we'll call that a, we'll call that a. Just trust me on that. And then we know that this is going to be a. We know that this is going to be 2a, and this is going to be a radical 3. So we're looking at the tan of that, which is opposite over adjacent. So the tan of negative 330, therefore, is going to be a over a radical 3. Now, it is the case that the a's will cancel, which is a beautiful thing. So that gives us 1 over radical 3. Many teachers don't like radicals in the denominator. So let's multiply both sides, or the top and bottom rather, by radical 3. And we would have radical 3 over just 3. And that is going to be the answer, radical 3 over 3. Radical 3 over 3. Notice how this a was positive because it goes up. This a radical 3 is positive because it goes off to the right as well. All right, so that's that. Okay, so it's kind of annoying to have to draw these over and over again, but we're just going to go with it. So when it comes to cosine of 210, once again, setting up the structure, 0, 360, 90 right there, 180, 270. 210 would land us around here. So we could draw a triangle here, and imagine that's 210 right there. So we're interested in this difference right here. This angle right here, that's going to be 30 degrees right there. All right, because 210 minus 180 is 30. And then adhering to this structure, the side opposite of 30 is going to be A, but we're going to call that negative A, and the reason is because it goes down. The side adjacent to the 30 is A radical 3, but we're going to call that negative A radical 3 because it kind of goes to the left from the origin. And then this one we're going to call 2A. Now the hypotenuse is always positive, so we're just going to call that 2A. So cosine is always, according to the structure, adjacent over hypotenuse. So therefore, we would be looking at this adjacent over the hypotenuse. So I'll just write that over here. Cosine of 210 is going to be equal to the adjacent, which is negative a radical 3, all over the hypotenuse, which is 2a. It's the case that the a's would cancel. And then next thing you know, you have negative radical 3 over 2, and that's an acceptable answer. Negative radical 3 over 2. Okay, looking now at problem number 43. So we have 0, 360, we have 90, we have 180, we have 270, and now we're analyzing 135. So 135 would land us like in here. So let's draw a triangle. Let's imagine that's 135 right there. So 180 minus 135 is 45. So that's 45 degrees. And according to the structure, this would be an A. This should be a negative A because it goes to the left, and this would be A radical 2. The hypotenuse is always positive. They want the sine. The sine is opposite over hypotenuse, according to our structure. Here it is. Sine is opposite over hypotenuse. So therefore, we are going to put the opposite side, which is A, over the hypotenuse. So let's kind of do that off to the side. We have sine 135 equals A over A radical 2. The A's would cancel. Next thing you know, you have 1 over radical 2. And then at that point, let's see, you could multiply the top and bottom by radical 2. Next thing you know, you have radical 2 over 2. And that is the answer to that one. So radical 2 over 2. Okay, so looking at problem number 45, if line XY and line XZ are tangent to XY is 6, so that's right here, and the radius of the circle is 3, so that's 3, that's 3. Find RX. They want us to find this. Okay, if these lines are tangent, then that's 90 degrees. Okay, and therefore this triangle is a right triangle, which means we could use the Pythagorean theorem to find this yellow part, which is what they're asking for. So I'll kind of draw it over here, 3, 6, and then we want to find, we'll call it C. So 3 squared plus 6 squared equals C squared. So 9 plus 36 equals C squared. That's 45 equals C squared, and C would therefore be the square root of 45, and then C could be said to be 3 radical 5. Okay, so that's that one. 46, solving for angle B, rounding to 2 decimal places. Okay, so let's see. We could use the law of sines here. So we could say sine of 42 over 10, because that's this over that, sine of this angle over this side length, is going to be equal to sine of B, angle B, which is right here, over this opposite side length there. Okay, that's the law of sines. So at that point, multiply both sides by 7. You would have 7 sine 42 over 10, and that equals sine B. But the thing is, we want to find the angle, right? We're trying to find this angle. So what that means is we have to recognize that the angle is going to be equal to the inverse sine of all of this stuff right here. Okay, so whenever you're trying to find the angle, that's when you want to use the inverse. So therefore the answer would be approximately 27.93 if we round to 2 decimal places. All right, 47, find the value of x rounded to 2 decimal places. Okay, so whenever I see this sort of side angle side structure, that makes me think we got to use the law of cosines. So it would be the case that the angle is going to get cosigned, okay, and the side opposite is going to be the thing that's on the other side of the equal sign. So it's going to be x squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 34 degrees. At that point, we're looking at 100 plus 144 minus, let's see, that's 20 times 12, which is 240. And then we have cosine of 34. And that equals x squared. So x would really just be the square root of all of that. And I'm sort of comfortable with just doing that in the calculator. I like to use Desmos for this stuff. And that turns out to be approximately 6.71 if we round to 2 decimal places. All right, 48. In the figure, identify each part of the polyhedron with the correct vocabulary. Okay, so GH is right here. So the bases of this, it's really, we could say it's a triangular prism, right? Because you have this triangle that matches this triangle, and you have these sort of edges that connect the vertices of the 2 triangles. So it's a triangular prism, which means that the triangles could be considered bases. So this GH right here is a base edge. Okay. Looking at problem letter B, they want this. That is a vertex because that's just a point. That's like one of the corners, you could say. CDE, CDE. Well, that's a triangle, of course, but it happens to be the base, one of the bases. Let's see, EDGH, EDGH. So this is a plane, but in the context of a triangular prism, we would call that a lateral face. Okay. So these are the bases, the triangles are the bases, and these flat parts that are surrounding are lateral faces. Okay, and the points are vertices, and so on. All right, 49. What's the measure of each angle shown? Well, we know that this is negative 90 degrees because typically angles, positive angles go counterclockwise. So since this is going clockwise, it's definitely negative 90 plus an extra 20. So we're looking at negative 110 degrees. Okay. And we know that it's negative because we have this arrow here that's sort of communicating to us that, yes, we are indeed going in the clockwise direction, which makes this angle negative. This is a positive angle because we're going in the counterclockwise direction, and then next thing you know, we end up right here. Now, the reality is that this whole thing is 270, right? 270. So it's going to be 270 plus that extra 80 degrees, which makes it 350 degrees. All right, so that's 350. Okay. Problem number 50. Name 3 angles that share the same terminal ray as 240. So this actually is going to be pretty easy. I mean, 240 is like right here. And, you can imagine another angle where it does that, but then it does a full revolution and lands on top of itself, right? You can imagine that. You could also imagine an angle that starts here and then lands there, right? That's another possibility. And then you could imagine another angle that, does what the red thing did, but then does it again. Okay, so I know it's probably getting confusing. So let me just draw the original situation again. So that's 240 right there, 240 degrees. So let's do that first case scenario. It would really just be 240 plus 360, right? Because imagine if we had some angle that hit 240 but then did a full revolution around. Well, that's going to be 240 plus 360, which is 0, 0, 6. So that's 600. 600 degrees would totally work. Now, imagine we took into account this negative angle that lands on this angle here. Well, that would be 360 minus 240, right? 360 minus 240, right? So that would be 120 degrees, but since it's negative, since it's going in that clockwise direction, we would say that it's negative 120 degrees. So far we have 2 answers. We have 600 degrees and we have negative 120 degrees. And finally, I say we just take into account the fact that, yeah, we could do the 600-degree thing where it's like it goes here and then a full revolution around, that's 600 degrees, but then we could do another full revolution around and land on this angle again, right? Couldn't we? So that would be 600 plus an extra 360, which is 960 degrees. All right, so that should work as well. All right, looking at problem number 51, write the equation of the circle pictured here. Well, we definitely want the center, which might not be easy to find. So it really looks like the center is right there. And that's 1 tick mark, 2 tick marks. So that looks like it's 2, and that's 1, 2, 3 down. So that looks like it's -3. So the center appears to be 2 comma -3. Now the radius we need as well. So that would be 1, 2, 3, 4. So it looks like the radius is 4. Now, constructing the equation of the circle, therefore, would be a matter of, adhering to the standard form structure. Okay. And what we have is x minus 2 squared plus y minus -3, which is really y plus 3 squared. And that's going to equal 4 squared, which is 60. And let's just get that over with. So that should be the answer there. Problem number 52. If PV equals 16, what is the radius of the circle? Okay, so if this whole thing is 16, then we know that this part is 8, and this part is also 8, right? And we want the radius of the circle. So let's see. All right. Well, I can immediately see, here's the center. And then we have that right there. Now that is the radius. If you think about it, right, we could call that R. Yeah, and hopefully you can kind of see that this yellow segment would also be R. So the two yellow segments are equal. And they're both R, right? The radius, right? The yellow parts are the radius. So it makes sense that this piece right here should be the radius minus 2, because this piece is 2. The whole thing is R, and this part is 2. So this part has to be R minus 2. And in that, we are forming a nice sort of right triangle right here. So I say we work with that. Let's extract that triangle so we could see a little bit more clearly what's going on. This is what's going on. So we could use the Pythagorean theorem. We could say 8 squared plus r minus 2 squared equals r squared, and therefore we have 64 plus, now r minus 2 squared is really r minus 2 times yet another r minus 2. We could FOIL that. That's going to be r squared minus 4r plus 4. So it's going to be 64 plus r squared minus 4r plus 4, and that equals r squared. Now the beautiful thing is that the r squareds will cancel. Next thing you know, you have negative 4r plus 68 after combining like terms equals 0. Let's add 4r to both sides. We have 68 equals 4r, and then 68 divided by 4 is 17. Okay, so we just found the radius. The radius happens to be 17. Okay, so that is the answer to that one. Hopefully this was helpful for my student. Hopefully this was helpful for others as well. And I will see you all later. Bye.